Thank you, Rachel, for the invite and the introduction. Looking forward to, again, having these in person someday, but this is fun as usual because we do get people from all over. I don't know, do you typically keep questions towards the end, Rachel?
Oh, sorry, I forgot to cover that. You can put questions in the chat window if you want to ask during the presentation, but maybe it'd be helpful to do a session at the end too.
Sure. And if there's any detailed questions, I may have to just skip them or address them afterwards, or we can take them offline too, because I know I have a lot to cover. I want to get through it and be mindful of everyone's time as well. So just a quick intro about who I am. I started my career working in biotech and learning R around 2005 or so at Children's Hospital, analyzing gene expression data. So that was really how I got my start into kind of the data science world. I then did a few other biotech companies and data startups until I tried a big company thing, got back into healthcare, and at that point had been juggling a few side projects and contracts, so decided to take the leap and go out on my own. And that's when I started TCB Analytics, and I always include my personal assistant, Porkchop. I should probably start updating the pictures of him to put some variety on this slide. But if you hear him, you may hear him in the background at some point, just hopefully not though. So what is anomaly detection? At a very high level, it's a fancy sort of outlier detection. I was actually explaining this to someone today, and I had used an example of height, and actually in this one, the cat is clearly different. But it's also looking at maybe things like height outliers. Gets a little more involved than that though. So as compared to just regular outlier detection, say with 1.5 standard deviations above or below the mean, this technique builds upon generalized ESD. It's called extreme studentized deviate test, which is very basic. It removes one outlier at a time. But this technique also employs several time series decomposition techniques and some robust statistics for detecting anomalies, and with the goal of reducing false positives while also capturing as many as possible. It employs something called a piecewise approximation of the underlying trend. And what this means is essentially like a rolling window, you can imagine, in order to minimize the number of false positives. So it actually looks at the median, since we know the mean can be not as robust outliers. It's looking at essentially a rolling window of median values. And I'll mention at the end as well, this package was put out by Twitter and completely open sourced. And if you're interested in more detail beyond what I'm going to talk about here on the algorithmic side, I will definitely recommend a paper at the end to read. It's really well written and I think pretty easy to understand. This technique also accounts for both intraday and weekly seasonalities. So some techniques only focus on global anomalies, and some are only on local anomalies. This accounts for both. So you can capture those really massive, obvious outliers, but it will also find smaller localized anomalies because of this piecewise approximation. And so here's what the piecewise median looks like. These are the authors just comparing these different techniques. And so these are the approximations of the actual time series. The piecewise median is the red one, and you can very clearly see that it's kind of this almost change point detection in a way. Like there's these different segments, whereas the other two pretty common classical techniques, quant spline, quant linear, employ a loss smoothing, and it's much more. You can see like it's very smoothed out, and you're going to miss various breaks and trend changes in this time series. Now, the authors did pretty significant testing on using Twitter data. So they were actually looking at just like Twitter activity and found that the piecewise median performs as good as, if not better than, these other techniques, and is also 4 times faster and reduces the number of false positive anomalies that are identified. So overall, pretty powerful algorithm. So that's all I'll touch on the algorithm side, but there's a lot more to get into there. Again, the links will be at the end, but I want to also talk about this. I've always been pushing this rapid prototyping technique. Some people are probably sick of me talking about it. It's basically a way for data scientists to demonstrate value before doing a full-scale implementation of any product. So I've seen so many companies start to build massive like Hadoop clusters, or spend millions of dollars on hardware and software and these different vendor solutions without even demonstrating value at a small scale on the data that they plan on doing the full-scale implementation on. And the other reason it's valuable is because oftentimes building data products, and as a lot of you are probably aware, there are so many unknowns and unpredictables with data when you're diving in and doing things. And I'll talk about some of those in this talk. But it also enables data scientists to do what they're good at. So especially with Shiny, you can actually prototype and build things very quickly and discover things along the way. So you've probably seen massive requirements documents. This is like what you imagine it will be like. And then you start building the product and you run into all these crazy things in the data and missing data and foreign characters and just filtering problems and sample sizes. And so in reality, I think being able to iterate quickly and building and letting a client or a user react to something iteratively is a much better approach. So, you know, rather than the client telling you they want this, you build it and then they say, actually, I realize I want to go off-roading or have kids, here's an SUV. That's the main idea. So I'll get into the first use case. Use case one, one of our clients creates hardware that is deployed in major hospitals around the country. And this hardware involves various types of testing for patients. The instruments have sensors on them that relay quantitative metrics, which can help diagnose any kind of hardware failure. So previously, the team was having to manually identify when an instrument would fail, but it was already deployed in the field, already being used at hospitals. And then they'd have to not only do a retrospective analysis on the data, but obviously we want to catch those before they get sent out into the field. So we thought that this was actually a perfect fit for anomaly detection. So let's talk about what the data looked like. So there were various metrics coming from these machines at various time points and different aggregation types. These aggregation types are things like the measurement at 24 hours, or the average, or the last however many minutes. So that's a lot of, as you can imagine, time series metrics coming off these machines for dozens, probably more, of different variables. So what we did was we identified with the client a couple of variables they were really interested in that they knew were indicative of problems. So we had kind of a true positives to test with. And this is the anomaly detection function. These are some of the parameters that we played with. And the couple that we experimented with for this problem was looking at the number of max anomalies to detect, which would just be, you know, if you put 50 there, it would calculate 50% of the data, up to 50% of the data being anomalies. So you can kind of limit that or increase it. The direction, so in some use cases, you only care about, say, spikes that are going in the positive direction. In this case, the client did care about positives and negatives. The alpha, which is a level of significance, so we wanted to see how sensitive or not this algorithm was for this data. So you specify that as like a 95% confidence, 99, and so on. And then a piecewise median period in weeks. So that rolling window I talked about, Twitter found that the default of 2 actually worked the best, at least on their data. We did play around with that, and it turns out that that actually was the ideal value as well for this data set. And Rachel, if there are questions, I can't see if any of them are coming in. You might just have to let me know.
There was one question, but they said we could save it to the end. But
Okay.
Can you use anomaly detection methods to study mortality?
Cute. Let me see.
And,
How come I can't get the chat window to pop up?
and we can,
Oh, there we go. Okay.
we can,
I can't get the chat window to pop up. All right, I may just have to use them at the end, but that's a good question.
Okay.
It does. I think you can use it. So this package, it doesn't even have to be strictly on timestamped data. That's another nice thing. It takes I can take a numerical vector as well. So it will apply the same technique to just a vector of numbers. So hopefully that answers the question. And then we also experimented with removing major outliers before running the anomaly detection, because we discussed with the client that sometimes these machines just throw out these crazy numbers that are like obviously wrong. And that's just, the nature of the beast of when you're working with data sometimes, and these machines aren't perfect. Because the data you input into anomaly detection very much affects the results, it's highly sensitive to what's inputted. And I'll show you an example here. This was a chart that we originally created when we were in the early prototyping process, and we didn't remove any outliers. And you can clearly see like these values are just astronomical compared to most of the values here, which are just box plots over time. Then we remove the outliers based on some rules the client gave us, and this is what it now looks like, and there were actually no anomalies detected. And in some cases, you may even see that an anomaly may get detected, say, here. But this was a case where removing those outliers actually removed some noise from the results. So we kept wanting to experiment with these different things and parameters and find what was the best mix for this data. And it will be different for every data set, but this is what it looked like. It was literally, you could see each file name had different alpha values, there were different variables, whether we removed outliers, and it was a very iterative, just kind of, literally spitting out dozens and dozens of PDF files and manually looking at them. So we'd be going through like this with the client, finding real ones, what's fake, what's real. And turns out that is a really, really good use case for Shiny. And even if we weren't delivering a Shiny solution, for me, it would be way easier to just do this. So I put all those variables as dropdowns on the side here. So now I can just quickly, change them and get that instant feedback and not have to pre-populate or go through every single possible combination of parameters. So we built this, and what we did was we gave it to the client and said, just play around with it. Let us know what you find. Let's see if it catches the real anomalies that you gave us. And once we got to a point where we all felt comfortable that yes, this is catching real anomalies, it's not bringing back too many false positives, then we settled on basically the values that those parameters should be. And we did end up removing outliers, and in most cases, our outlier removal rule ended up being 2 times this was the IQR, so that was our 2 times standard deviation above or below the mean. All right. Now the next screen is actually how we ended up presenting the data to the user when they log in. So once we got past this kind of rapid prototyping version, we got to, well, let's get to more explanatory and let's alert our users to what's important and what they should pay attention to. So then they come in, they log into the app and they see this. What you're seeing here is the date range that they care about. They want to find anomalies in the first 2 weeks of April. So the algorithm runs in all these various permutations, and then it says, hey, we found 25 high significance anomalies, 14 medium, and none that are low. What the user can then do is, and the reason some of these are highlighted in red is because they are also outside of the allowed threshold for that particular measure. So they gave us all the various limits. And so that means it was not only identified as an anomaly by our algorithm, but it was also a known outlier in the system and should not be above that value anyway. So probably like doubly pay attention to these ones. So you can, from here, we started to develop email alerts. So the user would could figure out which alerts they want to receive, whether it's just these red ones, whether they do want to receive these ones. But rather than blast, your users with alerts, especially if they're going to be false positives, and then they just lose all confidence in your tool and your algorithm, you go through this iterative phase together with them instead. So from here, and again, this is a really good example, I think, of an explanatory dashboard where it's telling you something, it's alerting you to something. Now you can click one of these and actually see the chart below, but what it will also do is pre-populate on the next screen all the different parameters here and allow the user to now dig in a little more. And that's just like a huge time savings rather than having to go, set these again. And this is, I think, the exploratory side of a dashboard where you have probably analysts and users that are interested in diving into the details of the data a little bit more. And so let's look at the code. I know everyone wants to see a little bit of code. This is what the input data looked like once we were done kind of pre-processing it, transforming it. You have a timestamp, and then you have, for a particular measure, you have the values. And you can see that there's sometimes days missing. The algorithm does not care about that. This is more for labeling so that we know what date the anomaly occurred on. So you can provide just a vector of numerics like this. So what we did for the anomalies, as you saw, the high, medium, and low significance, we iterated over the 3 different alpha values. We just chose 0.01, 0.05, and 0.1, which would be 99, 95, and 90% significant. We store all of them in a list. And then we use also 1 year of data prior, because this technique does rely on having enough data to identify seasonality. So we just chose 1 year prior to the date range they're interested in. So if a user is interested in finding anomalies the week of May 1st, 2020, we also provide the data starting from May 1st, 2019. And that is our input. And here's the code. Very simple. It's 1 line once you get the data in the right format. I use direction equals both. The alpha is passed here, and there's just a for loop. And we chose 30% of the data to, well, identify at max the number of max anomalies up to a percentage of the data, which is 30%. And the reason we have a try and silent equals true is if there is not enough data here, or if there's nothing returned, we didn't want the app to error out, so it just fails silently. I'm gonna pause there for a second and see if I can find this chat box. Okay. Oh no, I have not. I will. That's interesting. Someone mentioned our intro.js for tours of Shiny apps. That sounds really awesome and probably great for some of our clients as well. Okay, I'll go back. It looks like all of these can be answered later. The other thing is, in addition to all the fancy stuff we did, our client also just wanted, those rules I mentioned, they have different limits on different measures. They just wanted to see those outliers by week. So this is another great thing where Shiny comes in handy. You can just click, there's a ton of outliers for some reason the week of March 1st. They can click that and then just see them all. And that's something they could never have built internally quickly or easily. Well, for Shiny, this is extremely simple. So that's the manufacturing use case. Looks like I'm good on time. The next use case I want to talk about is with a sports technology company, and that researches essentially up and coming trends in sports tech, how to keep fans engaged. Obviously now during COVID, it's even more important to somehow keep people interested in sports. Identifying trends like VR and AR used in whether it's stadiums or wearables on athletes. And so the way their business model works is they actually curate thousands of articles on these various things like specific sports teams and what they're doing, who they're partnering with, leagues, different vendors, and who they're sponsoring. And they're using, there's a whole bunch of tools, but if you can use Feedly and Diffbot to help with storing all of these articles, finding the articles, and tagging them, essentially, and structuring them for applications like this. So the data becomes, like I said, articles. It does this kind of analysis. It's user fed in the sense that you start to tell it what's important to you and what you want to monitor. And what we end up using are the number of mentions of these various entities, number of mentions over time, like vendors, teams, like how often are the Red Sox being mentioned in the press and why. And so this, in order to identify, we thought, up and coming trends or breakout trends in sports technology, also perfect fit for anomaly detection. So here's what it looks like when you log in. This is we're running anomaly detection on Teams. And so you'll get a listing here of an anomaly that was found for a specific team. Over here, you're just seeing some basic summary statistics on the mentions and whether they've increased over week or not. And so what you'll get when you click one of these teams, like I want to know why the Seattle Sounders were mentioned on August 18th so many times, and why did anomaly detection pick it up? And so that the orange circles up below are the various anomalies. You can click it, and it will pull up the articles that are kind of contributing to that spike. And you can quickly see, even just by skimming, that it was clearly about the Amazon Prime Video becoming the streaming partner of the Seattle Sounders. So this, again, was an example of an internal business analyst tool where we kind of iterated until we thought that we were getting something interesting. And eventually you could imagine turning this into alerts, whether it's for clients that want to monitor various topics. This is also a really good use case for any kind of market research. So if you're imagining even things like wines, we have a potential client that wants to predict varietal trends, like why does rosé suddenly become popular? Why does certain canned wines suddenly break out? And you'll find what we've found so far is usually it's a very big increase in the PR around the brand or around the team. So something like a celebrity sponsorship of a wine will just increase its publicity, which then in turn usually increases its sales. So another interesting, here's where we track vendors. So we noticed Pepsi spiking in the data, meaning Pepsi all of a sudden was mentioned a little bit more than not. And see, this is why anomaly detection is interesting. Obviously, this one gets picked up. Standard deviation, outlier detection would pick that up. But then look, it kind of normalizes off. And if you were just doing standard deviation above or below the mean, probably none of these would get picked up. But because it notices, oh, things have normalized and stabilized a bit, it's suddenly there's an uptick. Anomaly detection notices that. And so again, oops, we click it, and quick skim shows that Pepsi, the women's championships added Pepsi as a sponsor through 2025. And so you could imagine even, we started to even automate this part where you just do a tokenization of the words and figure out exactly what's happening quickly. But one last interesting piece to anomaly detection that can be used for is data quality control as well. So obviously data is messy and none of these tools are perfect, but and machine learning is always everything's getting better and better, and AI is constantly learning. So here was a really good example. We noticed that the Ottawa Senators were spiking, and everyone was like, who even is a fan of the Ottawa Senators, and why are they talking about them? Because there was nothing big going on, no playoffs, no nothing. So we looked into it. It turns out that there was a big acquisition of what's called an over-the-top streaming company. So Diffbot had tagged this over-the-top streaming service as OTT because that is the abbreviation for OTT. OTT is also the abbreviation for the Ottawa Senators. Auto centers, not the same as OTT streaming. So this was like one of those edge cases where, you actually work with the vendor, they'll fix it, their algorithms get better and learn about your use case. This is where, NLP and text analysis is so difficult. But I thought this was really interesting to actually surface maybe problems in data that you otherwise just wouldn't have found because it's not completely obvious unless you're manually skimming every single, article. And so almost at the end here, which is going to leave a lot of time for, I think, questions and discussion. The package I use is from Harbor Master on GitHub. He does awesome work with he makes so many valuable packages, but he forked Twitter's anomaly detection and made a few improvements to it. So I actually use his. The two core functions, he modified them to return tibbles, and he uses shorter snake case aliases, removes some overhead from just these functions in general, so it's a little faster. I also just ran into a few bugs with for some reason, the Twitter one, and I resolved them by just forking his version and using his. So personal preference maybe. And lastly, there's a bunch of links in here if you're interested in more about the statistical approach behind all of this. My first recommendation would be to read this one, publication 1. This is the paper that Twitter actually released, and they released all of their metrics and testing results. And again, the piecewise regression is actually 4 times faster, or piecewise median, sorry, 4 times faster than these other techniques. So I know that was a lot. I always want to make sure I cover everything and leave enough time for questions. So I'm happy to go back to some slides or answer any questions.
Awesome. Thank you so much, Tanya. That was great. And so helpful to see some of the actual use cases that you're working with. I think Connor has a question in the chat that says, does anomaly detection in general have a bias towards identifying the last record in a vector as an anomaly?
Oh, that's a good question. So no, but that's funny you asked because this algorithm will not. It doesn't like weight recent events anymore. However, there is actually a parameter in the function that allows you to only identify the last one. So that will obviously be faster as well. But if you're only interested in, say, anomalies from yesterday, it's a quick way to make sure that you're only looking for the last recognized anomaly.
It looks like Nate had a comment about he's been using Cicerone and people really like that. Is that?
I am not familiar with that. Do you want to talk about it quickly? Is that Nate?
Oh, it's a I mean, I didn't design it. It's a package that is really cool for doing guided tours of Shiny apps. You can like press a button and it will like highlight certain areas and walk you through it.
Oh, that's the one. Yeah, David had also mentioned our intro.js. Are they similar?
Yeah. So I hold on. I'll put the link I'll put the link in the chat.
Cool.
And then another question, Adam just asked us, how generally applicable is this process? Could we use it in academic and industrial applications?
Absolutely. I don't see why not. It really, you can give it time series data that's timestamped or just any numerical vector. The thing that's nice about it is, even not going totally under the hood and understanding how every little thing works, you just kind of test it. That's kind of the bread and butter of machine learning these days, like see what sticks. But yeah, I think what I usually recommend is get as many ground truth anomalies as possible so that you can test and train and find what works so that you're ultimately minimizing false positives while maximizing your sensitivity. And yeah, I'm happy to answer specifics if you have any use cases you're not sure about, but fairly straightforward to use. Like I said, it's here's the data, the input data, and you could just drop a timestamp even and just give it a numerical vector as well. And there's actually also a way to quickly plot the results built into the package. So it makes it visual inspection really easy.
Kramer, I want to make sure we answered your question fully too. I know I didn't read the full thing during the presentation. But if we go up.
Oh yeah, I see it.
Okay.
So in a data set of say 6 million records, there might only be 3K deaths. So the deaths might be an anomaly. So you're saying the 3K deaths is like a much lower value than the norm? I stuck using GLMs, he says. I mean, I think if that's...
Can you hear me?
Yes.
I'm just, okay. So yeah, the issue that we have in life insurance is it seems to me like we're not able to use the cooler machine learning algorithms because there's so few instances of the target variable being, like a 1 in this instance. So you might have like close to 6 million zeros, just a handful of ones, because, your like incidence rate is so low. So I think what Kyle sent could be a helpful rabbit hole to go down as well. But just wondering, like, essentially your deaths are an anomaly in that data set. So I was just curious if this could handle that kind of use case.
Yeah. Are you saying, are there only zeros and ones in over time?
Right. Yeah. It'd be like 0 for all, let's say you have, like policyholder data in this instance. So you have all these monthly records for people when they didn't die. And then you would have, records for the ones that did die that would be tagged with like a 1 for a death or just like true for death or whatever. So with a GLM, it kind of lends itself, I guess, nicely to that problem. You're just modeling like, is death 1 by whatever variables? But I've had issues trying to use other algorithms for that kind of problem.
That's interesting. Yeah, I'm not sure. I wonder if like, if you care more about groups of consecutive ones or abnormal patterns of the ones, that could be something. Or if you can change it to be like cumulative deaths over time, to maybe some sort of more count data, it might be more of a fit for this. But it's totally going to depend on if you're able to do that with your data.
Okay. I mean,
and
that
how
could
you
be
want to
a good way
interpret
to
it.
test whether your current model is working well, I suppose. Just kind of like run in real time. Are we seeing like a spike in deaths that we wouldn't expect otherwise?
Yeah, exactly. I'd probably try, if you can get away from the 0-1 just to like confirm how your current model is working. I think that would be an interesting approach.
Okay. Thank you.
Yeah. Isn't this just an issue of having a balanced data set? How so? Do you mean like, okay, I'll take it back. I mean, balance in terms of like if you're looking at training data set, but this is looking at just the actual values over time. Oh, you're talking about Kramer's data, right?
I think so.
Yep. Sorry. And I will say, like, I think I've used this in other applications too with Twitter. Even Twitter mentioned data for various topics over time. Anything where you have like count data or metrics or values coming off a machine. Because initially when we thought about this problem, we thought, oh, let's take a really complex like machine learning approach and combine all these metrics. And it turns out it just wasn't necessary. We were able to, I think we found like 95 to 99% of the clients known anomalies with this technique, and we're not flooding them with noise either. And it just then becomes a matter of kind of fine tuning over time. So it obviously helps to have a client that's more collaborative and willing to work with you. That's made this process very enjoyable and pretty easy. And then I do think this market research use case is also pretty interesting. You can imagine doing this for stock coverage news. Like I said, we're predicting wine trend breakouts. You could run this on Google Trends data. So really anything. Yeah, and Connor, I think that's exactly what that's what I was getting at, is like a rolling cumulative death that resets might be a good way. And then you may have to play around with the piecewise median defaulting to 2 weeks, depending on when that reset is every n days. You just may want to play around with that.
I think there was a question up above about the Twitter package. Oh, does anyone
Sure.
maintain?
Is it maintained? Is that what the question was?
Yeah, it is.
I believe so. Let's see. Not since 2 years ago, Harbor Master, you're slacking. No, I haven't had any problems with it. And there may even be, this branch is 27 commits ahead of the Twitter master branch. I haven't used the Twitter one in so long and haven't had any issues with this one. But he's super responsive. I'm sure sorry, I'm not trying to give him like more extra open source work, but I'm sure if he has time, he'll help you out if there's any major glaring issues. And, I always encourage people to help contribute to it if you can too. I haven't done any commits to this code because I just haven't needed to, but it's always another good way to kind of dive in.
I think one other question that I see was maybe a private one to me, but if the slides will be available later.
Yes, absolutely. I'll send those probably in the PowerPoint format so that all the animations are there and there aren't any overlaps. Yeah.
Perfect.
And we'll actually be, I think, writing up some more, another blog about this, maybe with some different information. This is actually pretty brand new content. No one's really seen this yet, so you guys are kind of I may be presenting this at an upcoming conference, but you guys got the first sneak peek. Very lucky.
Nice. Have you done any virtual conferences so far?
I haven't. I'm about to do Bio IT World in October, and then we did submit this to talk at, I think, the RStudio Conf, but it may evolve and change a little bit by the time we present this.
Mm-hmm. Well, I'm curious how all the virtual booths work out too.
That will be interesting. Yeah, you can't really give out. Can you give out virtual swag?
Yeah, I'm not sure how to do that. People have been asking for stickers, but I haven't been in the office since March, so
Oh yeah,
we're all locked up. And one other question, can you quickly talk about the Slack group you mentioned earlier?
yeah. Just as an overview of it, the reason I started it was when I went out on my own, I really didn't want to be just cut off from all these awesome people I've met and coworkers and friends, people I meet at conferences. And I also found even before that, I was always connecting people and wanting people to meet other people. And I just figured it was also a good way to streamline that, just streamlining introductions. And it helped me like keep in touch with these people and just stay connected and stay up to date on my technology and what I'm doing. So it started out organically. I just invited like coworkers and friends that I knew, and they can invite people they know. And it's still small enough and active enough that it has like a small feel to it. But we used to do in-person events before COVID, like once a quarter if we could. It's just at various places in Boston. Now we're doing some virtual tech talks. We have like a jobs channel, an R channel, Python channel, freelance, video games, food, you name it. So it's just a place for people. No recruiters allowed. It's a place for people to talk, privately about any kind of issues or getting help or career help or wanting even technical help. And there's just some really good, I think, stuff that goes on in there. Really, really interesting conversations. So shoot me a message if you're interested, and I'm happy to get you an invite.
Cool.
You could probably just message me on Twitter or email me I'll just put my email in here. That's my direct email.
Does anyone else have any other questions for Tanya? Oh, we can't see your email. Or I can put it in the chat window too.
Okay. I was pulling up this, someone else listed an interesting paper. Thank you.
Something else that I was just curious about is I always love to spread the word of other meetup groups. So I was just curious if anybody that's on the call right now has another virtual useR group that you want to share information about, or any other upcoming events.
I wish I knew more.
Oh yeah, and it doesn't have to be R. Anything would data science. I think there may be a virtual Pi Data Boston meetup tonight too.
I think there was an Our Ladies meetup, but it was like San Diego.
Oh yeah, there is. Oh yeah, there is an Our Ladies Boston event actually later today too. So I'm just going to put that one in the chat window.
Oh, nice. Yeah. There's like sometimes too many events to track.
I know we were trying to pull in all the different useR groups into one place to be able to see that. And I think maybe the Meetup API stopped working for that, or you had to pay. I'm not sure what happened, but oh, Open Data Science Conference. Is that one coming up soon, Adam? Oh yeah, Earl.
Earl too, yeah. I think they're completely virtual. Tableau is doing a completely free virtual one too.
Nice. And I know our studio conference, and I saw some people mention that about the not getting a t-shirt, and unfortunately that will be virtual as well. But I'm excited for that. Any other last final questions for anyone? It's nice to have the extra questions time and time to just network with everyone. And that's one of the things I do miss about the in-person meetups.
Yeah, I know it's not really the same, but I will get the slides out for everyone, and yeah,
Okay.
feel free to message me with questions. I love like bouncing ideas about stuff like this off people too. So even if you see something I can do better or improve here, you know, always interested. So some people that maybe have been working with this package already.
Perfect. And one other thing I just wanted to say, if anybody else wants to speak at some point, and someone just mentioned to me maybe doing some lightning talks for perhaps October or November. So if anyone wanted to do even just like a 10-minute presentation, I'd love to put together a series of lightning talks too. But thank you all so much for joining, and thank you so much, Tanya. That was awesome. I really appreciate you putting this together for us and letting us see it first before the conference.
Yeah, no problem. Thank you all. Thanks, Rachel.
Thank you. Have a good rest of the day, everyone.
Bye.
Bye.